Hello everyone, and welcome to this video where I'll be taking you through a question on the objective called Write the parametric equations of a curve in y equals f of x form by eliminating the parameter in polynomial and radical equations. So in this video, I'm going to be at the site Knewton.com and working on a question from their Knewton Alta homework system related to this particular objective. And I'm just going to be doing one question. And hopefully when you're working on similar problems in that same objective, watching me go through this one here will help you out when you're working on your own. And the one I'll be working with is a polynomial one. And the radical ones are very similar. So you can do the polynomial one I'm about to do. You should be able to do the radical ones as well, the ones with roots. All right, so here's the site, Knewton.com, Knewton Alta. And again, I'm in an instructor mode, so you're going to see things a little differently than me. We're on this objective, right, where we're writing. A lot of these are eliminating the parameter, writing the equation in rectangular form. So without the parameter, right, with just y and x, where the equation of the curve is in the form y equals f of x. All right. So I showed you the answer. Oh boy. But before I get into the question, though, I would suggest, as I do with all these videos, if you're somewhat familiar with the concept of eliminating the parameter in parametric equations, pause the video, try to work it out yourself first, and then come back, watch me do it, and compare your work to mine, see how you're doing, see how you're grasping things. All right. So in this one question I'm going to do here, we are asked to write the parametric equations below as a rectangular equation by eliminating the parameter. All right, so these are parametric equations. We have our x coordinate and y coordinate of whatever position we're at on the xy plane, the Cartesian plane. The x and y coordinate are dependent upon this variable called t, and this would be called the parameter that these two depend on. So x of t is 7t squared plus 1, y of t equals 8t plus 4. Okay, and we're asked to write the rectangular equation, meaning in just x and y only. And they specifically want you to solve for y. Now notice they have in the box here that you'd be filling in, they already have the y equals plus or minus, and then fill in the blank. All right, so I'm actually going to go about this the way they want, but the way I do it initially, I'll show you both ways. Right? So we're given these parametric equations for just that would trace out some curve. You plot different locations for different values of t, and then once you got enough locations plotted, enough points plotted, you can hopefully draw the rest of the curve. I'm going to go to that desmos.com free online graphing calculator site to show you what this curve looks like after we're all done here. So the x coordinate in terms of t we said was 7t squared plus 1, and the y coordinate in terms of t was 8t plus 4. All right, so they end up, the way they're having you fill in the answer here is, they want the rectangular equation in the form y equals, and then some expression involving x, right? Over here will be some function of x, which I'll call f of x, right? That was in the title, the y equals f of x form. So to do this pretty quickly, I'm going to keep this y of t equation here. Y of t is just simply the y coordinate of whatever point I'm at, so I can call that just y and show how it depends on t over here, y equals 8t plus 4. This is already in the y equals form, so what I would need to do now is replace t with an expression that involves only x. So that'll come from the this first equation, right, where the x coordinate, which I'll just write as x, is 7t squared plus 1. And we're going to solve this for t. I'll write that underneath. I'm going to solve this x equation for the parameter t, and then we'll substitute this value of t in terms of x into the y equation. All right, so I subtract 1 from both sides. We'd have 7t squared on one side equals x minus 1. And I just switch sides here. Put x on the right, 7t squared plus 1 on the left, subtract 1. Divided by 7, we'd have t squared equals x minus 1, all divided by 7. Or you could write this as 1/7 x minus 1/7, whatever. And then you might remember your square root property. All right, so this is why they have the plus or minus there in the problem, is when I solve for t, t could be the positive square root of this x minus 1 divided by 7, or it could be the opposite of that, right? Both the positive square root and the negative square root when squared would give me this x minus 1 divided by 7. So t could also be the negative square root of x minus 1 divided by 7. All right, so that's why when I substitute this into the y equation here, there's going to be a plus or minus, right? Because it could be one with the plus, one with the minus. So we end up here after doing the substitution. I'll just write sub. Y could be equal to positive or negative, 8 times the square root of x minus 1 divided by 7. And then you got the plus 4 after that, right? Again, one with the plus square root, one with the minus square root. And that's what they want. All right, this right here, this is what they're asking you to do, right? These are the rectangular, this is technically two equations, right? One with the plus, one with the minus, but these two rectangular equations are the equations for the curve on the xy plane that would be traced out by our parametric equations, right? As we change the value of t. Could have also done it the other way around, right? Where instead of having this plus or, now again, this is what they want here. The y equals, some functions of x. But I could have also done this, right? So I'll just say or. This is an alternate version. Right? We had x equals 7t squared plus 1. Y equals, 8t plus 4. Could have done it the other way around too, where I took the y equation, solved for t. So t would be, y minus 4 divided by 8, or 1/8 y minus a half, or again, y minus 4 all divided by 8, same thing. And then substituted that for t, back here. Actually, I will do this version. So I'm going to sub this y minus 4 all divided by 8 for t here. We get x equals, 7 times, and then t is being replaced by just an expression with y here, y minus 4 all divided by 8 squared, and then plus 1 afterwards. And we get x equals, 7/64, right? Because 8 squared is 64. So 7/64 times the quantity y minus 4 squared plus 1. And you could get this in the standard form for a parabola, right? If I subtract 1 over here, we got x minus 1 equals 7/64 times y minus 4 squared, and there we go. This is also a equal, I mean, this too, right? Everything before this had just x and y in it, but this is in your, you might recall this, one of the standard forms for a parabola. This would be a parabola where the vertex was at the point 1, 4, right? 1 for x, 4 for y. So I'll plot that point here, and then this 7/64ths. All right, this was a 4 times p, where p was the distance to the focus, right? So the 4p is 7/64ths, right? Meaning that p would be 7 over and then 64 times 4, yeah, 296. All right, so we're very, very wide. The focus is very close, and it's positive here, so it's to the right. So there's the focus, and the parabola is going to be opening to the right around the focus, something like this, right? It's going to, so our my pink curve here, some parabola opening to the right. Now, if I did it with the plus or minus like earlier, right, the one with the positive square root, give me the top half of this parabola, and the one with the minus, the negative square root, will give me the bottom half of this parabola. And you'll see all that in Desmos here in a second, right? So let me actually go to desmos.com. Right, again, a free online graphing calculator site. So first I'll put in those parametric equations. All right, so remember, if you're going to enter a graph of curve with parametric equations on the xy plane in Desmos here, got to enter them as an ordered pair. Right, so parentheses, left parentheses, then the x coordinate in terms of t was 7t squared plus 1, then comma. Then the y coordinate in terms of t was 8t plus 4, close the parentheses. So you see part of this curve is being traced out right now, just this part here. When you do enter these with the parameter t, you'll notice it immediately automatically sets up a range of t from 0 to 1. All right, when t equals 0, you'd be at the point 1, 4. There's, there's the point 1, 4 right here where my cursor is rolling around. And when t is 1, you'd be at the point 8, 12. And, that's this point up here where, 8 for the x, 12 for the y. So you're only getting that part traced out. So if you want more of the curve, which I do, I'm going to just change, I'm going to just make this range of t values a little bigger. So say from -10 to 10. And then you're getting a lot more of this curve traced out, and you can hopefully see that it is a parabola, opening to the right, just like in my little rough hand drawing with a vertex at the point 1, 4, right? I might as well put in the point 1, 4 so we can identify the vertex real quick, right? Label it. Say the point 1, 4, the furthest left on this parabola, as I was stating earlier in my hand drawing. All right, well, those were the parametric equations. Right, tracing out this red curve, or whatever color you see curve. Now, the rectangular, when I eliminated the parameter, right, solved for t and then substituted in the other equation, we got these. Now I'm going to go in the y equals f of x form like they had. So remember, one was y, there were two equations. One was y equals positive 8 times the square root. You can just type sqrt of x minus 1. Oops, parentheses if I want it all over 7. X minus 1 all over 7. And then plus 4. Oop, get out of the square root. And then plus 4 after. And you see how that gives me the top half, like I mentioned, the top half. Right, you see that green curve popping on top of the red one there. I'm turning it on and off right now. But you see that with the positive square root just gives me the top half of this curve being traced out. And then I'll just copy and paste this and throw a minus sign in front of the square root there. And then y equals negative. I'll change it to green as well. Settings, change the colors. All right, and you can see that this y equals the negative 8 times the square root of x minus 1 over 7 plus 4. That other equation, right? That's the bottom half, right? I'm turning it off and on right now. Again, hopefully you can see that tracing out the bottom half of that parabola opening to the right. Yeah, both these together are the rectangular equations, right? The equations involving just x and y that trace out the same curve that our parametric equations do. Okay, and then I'm going to turn these off and show you the other one I ended up with, right? That one when I solved the y equation for t and substituted into the x equation and then put it in standard form for a parabola, right? We had x minus 1 was equal to 7/64 times the quantity y minus 4 squared. And you see this black curve show up. I'll turn it off and on again. You can see it's exactly the same curve that is traced out by our parametric equations. Okay. Again, what they want you to fill in the blank was the one with the plus or minus here, right? And there they are. Plus or minus 8 times the square root of x minus 1 over 7, then plus 4, which we got earlier. Right. Wonderful. All right, so this one had polynomial parametric equations. Again, when there are radicals or roots involved here, it's still the same concept. When you're asked to eliminate the parameter, you just solve one equation for t, substitute it into the other equation, and then you'll have your rectangular equations for the same exact curve. Right. And I hope that watching me do this and working it out helps you out when you work on similar problems on the same objective on your own. And thank you very much for watching.